You know, for literally thousands of years, we've been stuck on one of the biggest questions out there. What is consciousness? I mean, what's it even for? Well, today we're going to dig into a really groundbreaking paper. And what's so cool about it is that it uses AI not to try and create consciousness, but to finally put the major theories that explain it to the test.
All right, so let's get right into it. The central mystery is this. What is the point of consciousness? Seriously, is it just some weird ghost in the machine? An evolutionary fluke? Or does it actually do something? Something critical, something functional that we can pin down and really understand?
Okay, so here's how we're going to tackle this. First, we'll lay out the consciousness puzzle itself. Then we'll meet the little AI guinea pigs they built to solve it. After that, we'll watch 3 big theories go head-to-head in some pretty intense AI stress tests. And that leads to a really surprising twist about teamwork. And finally, we'll talk about why this is such a game-changer for AI. First up, the consciousness puzzle. For decades, the science of consciousness has kind of been stuck. The paper calls it a validation crisis, and there's a really good reason for that. See, to really test a theory about the brain, what you'd want to do is something called an architectural ablation. Basically, you'd want to go in and just snip out a specific part to see if consciousness goes away. But, for obvious reasons, you can't just do that to a living human brain. It's unethical, it's impossible, so we're stuck. And that brings us to the paper's absolutely brilliant solution. Let's build an AI guinea pig. I mean, if you can't experiment on a real brain, why not build the fake one where you have total control? That's exactly what they did, creating what they call the perfect model organism for this kind of work. And this is why it's such a game changer. In these AI agents, every single connection, every signal, every little artificial neuron, it's all completely transparent. You can see everything and you can tweak anything. So for the first time ever, scientists can run those impossible experiments with absolute surgical precision. All right, which leads us right into the main event. 3 theories face off. Now, don't think of these as some dry academic concepts. Think of them as the 3 main suspects in our little mystery. Each one has a totally different explanation for what consciousness is actually for. First up, we've got the Global Workspace Theory, or GWT for short. The idea here is pretty simple. A piece of information becomes conscious when it gets broadcast across the whole system. Think of it like a company-wide memo, or even better, a spotlight hitting an actor on a dark stage. Suddenly, everyone can see it. It's all about information access. Okay, suspect number 2, higher order theories, or HOT. Now, these theories say it's not enough to just have a thought or a perception. You're only conscious of it when your brain basically creates a little report about itself having that experience. So it's not just about seeing the color red, it's about knowing that you're seeing red. It's like having a quality control manager who's always monitoring what the brain is doing. It's all about self-awareness. And our third and final suspect is integrated information theory, or IIT. Now, this one's a bit different. It says consciousness isn't about broadcasting or monitoring, it's about integration. It's about a system's ability to weave tons of information into one single, unified experience. The analogy they use is great. A simple system is like a block of wood. You tap it, you get a dull thud. But a highly integrated system? That's like a crystal glass. You tap it, and you get this rich, complex, ringing sound that reveals everything about its internal structure. For IIT, consciousness is that rich, complex ring. So, let's just recap real quick. For GWT, the key function is access. That's our spotlight. For HOT, it's all about monitoring. That's the manager. And for IIT, it's integration, the symphony. Okay, now that we have these clear functions, the researchers could actually go and build AI agents based on each of these ideas.
And that brings us to the really fun part. The heart of this whole thing, the AI stress tests. This is where the rubber meets the road. They took these little AI brains and just pushed them to the limits to see which of these theories would actually, work.
And the very first result was, wow, just stunning. So they tested the higher order theory. They gave an AI a self-model, that's our manager, right? And then they just switched it off. Now look at the task accuracy. It barely budged. The AI was still doing the job just fine. But then, look at its self-awareness. It completely plummeted, right down to random chance. So what does that mean? It means the AI could still do the task no problem, but it had absolutely no idea if it was doing it right or wrong. It could do the thing, but it didn't know it was doing it. This is basically a synthetic version of a real-life condition called blindsight, and honestly, it's a huge point in favor of those higher-order theories.
Okay, next up, they went after the global workspace theory. They gave the AI a task where it had to juggle two different pieces of information at the same time. Then they started shrinking its workspace. And look what happened. As that workspace got smaller, the AI's performance just fell off a cliff. I mean, it totally collapsed. This is huge because it shows the workspace wasn't just related to the task, it was absolutely necessary to get it done. But this is where things get really interesting. The common assumption was that the global workspace, the big broadcast system, would make an AI really robust. But what they found was the exact opposite. On its own, the GWT agent was super fragile. And why? Well, it turns out that broadcasting amplifies everything, not just the signal, but all the internal noise and garbage too. The system only became stable when they added that self-monitoring part back in.
And this led to what is probably the single biggest insight of the whole paper, which they sum up perfectly here. The global workspace amplifies signals, but without a higher-order monitor, it also amplifies noise. To put it simply, broadcasting information without some kind of quality control is basically a recipe for disaster.
So, that brings us to the big reveal, the final twist in our story, a surprising teamwork. It turns out our main suspects, the big theories of consciousness, they weren't competing against each other at all. They were working together. So, the paper lays out this new, unified model, and it's basically a simple two-step recipe for building a robust, smart system. Step 1. You need a global workspace to broadcast information and make it available everywhere. That's GWT. But, and this is the crucial part, Step 2, you absolutely need a self-model to act as quality control, to monitor that broadcast and filter out all the junk. That's HOT. You need both. They work as a team.
So, okay, what's the big takeaway here? Why does any of this matter for the real world? Well, this research isn't just some abstract philosophical exercise. It has massive implications for how we build AI. It's about creating technology that's actually safe and reliable. What these findings give us is basically a new playbook for AI developers. First off, robustness isn't magic. You have to engineer it deliberately. Second, just broadcasting information is useless. In fact, it can be dangerous if you don't have a quality control system watching over it. And the bottom line is this: if an AI can't monitor its own processes, you just can't trust it. And that leads us to the final and maybe the most important question. For so long, the debate has been about the dangers and ethics of building a conscious AI. But this research kind of flips that whole conversation on its head. It suggests that these very features we link with consciousness, like self-monitoring and quality control, are not just optional extras. They are essential for making systems that are robust, safe, and reliable. So maybe the question we should be asking isn't if we should build these things into AI, but whether we can really afford not to.